So for number 17, we have to take this equation in point-slope form and transform it into slope-intercept form and then to standard form. So first, I want to move or distribute the 3. So I'm going to say y minus 8, 3x, and 3 times 5. We're going to add 8 to both sides. This gives us y equals 3x plus 23. Okay, so that's our SIF, since y is by itself. Now we have to take this and put it in a standard form, and that's when you just take that 3x and you move it to the other side. So if I subtract it, I have a negative 3x. That y is already positive since there was nothing in front of it. And then that's 23. Okay, now for 18, we threw a negative in there right here. So let's go ahead and bring our y plus 4 down. 2x. And then 2 times negative 6 is negative 12. We subtract 4. And we get y equals 2x minus 16. Now, for that 2x, we're going to subtract it to the other side to put it in standard form. So we have negative 2x plus y equals negative 16. Okay, now, for this one, you could go back and use the front of the packet again, of the homework, or of the notes, of the test, or the review, and find your formulas that you need. So this is write an equation in point-slope form. So we definitely need point-slope form. That passes through these 2 points. The problem is that you're given points. You're not given a slope. So you have to use this formula first to find your slope of these 2 points. Okay? So I would want to label my points, x1, y1, x2, y2, and I want to plug those into point-slope form. So I have y2, which is 10, minus y1, which is 6. And then I would do x's. So x2, which is 5, minus x1, which is 3. So this was to get my slope, my m. And so 10 minus 6 gives me 4, 5 minus 3 gives me 2, and 4 divided by 2 means that slope is 2. Now that I have m, and I have my first point, I need to plug it into point-slope form. Okay? So I'm going to jot this down right above it, and then plug in. So I've got y minus. y1 is already given to you. You could at least get that number, no problem. M you did have to find, so you would get a point for finding that m correctly. And then this x1, that's also given to you. So even if you just had y minus 6 equals blank, and then x minus 3, you're going to get partial credit. It's a matter of, can you plug in these numbers into the formula correctly, simplify if necessary, and get that slope, and then plug it in right there. Okay? All right. For 20 and 21, these two, just want to know, like, are the lines parallel, perpendicular, or neither? By looking at their slopes. So 8 and 1/8. Well, they're definitely not the same, because parallel was same. Perpendicular were opposite. Reciprocals, where you flip the fraction, and neither was neither of those. So I look and see they're both positive. Even though they're flipped, 8 over 1 and 1 over 8, even though these are flipped, they're not perpendicular because they're not opposites, positive and negative. So these are neither. Okay, in number 21, you have a positive 3 and a negative 1/3. So we see that they're opposite signs. 3 over 1 is really 1/3 flipped. Okay, so they meet the requirement for perpendicular. And then just a side note, if something was parallel it would have to be like the exact same number. So if I gave you m is 4, then the other slope would have to be 4 as well. Okay, so that's just a side note in case you come up with something that is the same. Same slope is parallel. For 22 and 23, I see here we got this bold endpoint slope form again. So we're back to this equation. Very important. Write it down if you need to write it down so that you have it. Okay. So I need to look to find my point, x and y, and my slope. Okay, so my slope, if I look here, it's 3x. And if I'm talking about a parallel line to this equation, this line, I'm talking about the same slope, so 3. My point is x1 and y1. I need to plug these 3 numbers into these 3 variables. So y minus y1 is 6. M is 3. And then we have x minus x1, which is 2. And lastly, we have this perpendicular one. So if I want a perpendicular slope to 1/4, I have to flip that around. And if it's positive, it has to become negative. So if I reduce this, we get -4. And my point, again, is x1, y1, the first point given to us. And again, I'm plugging that into this equation up here. So I've got y minus y1 is 2. Then I have my slope, which is -4, and then x minus a -3. And we know those two negatives become positive.